phase transformation of the electron and the structure of the atom, presented by József Garai, who is a retired professor from the University of Debrecen and now works as an independent researcher at SOB. The first modern description of the atom is Rutherford planetary model. He concluded this model based on scattering experiments of Geiger and Marsden, which showed that almost all the mass and the positive charge is concentrated in the middle of the atom, and the rest is empty space, and the electron orbits around the nucleus. 2 years later, Bohr used the Rutherford planetary model for the hydrogen, and in 1913, based on this model, he was able to reproduce the main emission lines of the hydrogen, the Rydberg constant, the radius of the hydrogen, and the ionization energy. This was an enormous success. However, the model still had a couple of shortcomings. The current quantum mechanical description of the atoms was proposed by Schrödinger in 1926. He was suggesting that the electrons can be described as a wave. This quantum mechanical treatment could reproduce all of the known features of the hydrogen atom. The wave equation predicts the probability of the location where the electron might be found. All the mentioned atomic models were assuming that the electron or electrons orbiting around the nucleus. These orbiting electrons in the atom do not emit radiations. This contradicts with electromagnetism. In order to solve this contradiction, Bohr was suggesting that electromagnetism is not valid at atomic scale. Atoms emit heat, light, X-ray, and gamma rays. These are different electromagnetic waves, and if electromagnetism doesn't exist at atomic scale, these emissions should not exist either. So based on the emitted electromagnetic waves, it is suggested that electromagnetism is valid at atomic scale. Accepting the validity of electromagnetism at atomic scale has very serious consequences. One, the point charge non-radiating electron should not orbiting around the nucleus, but should be stationary. If the point charge electron is stationary, then cannot be stable. This indicating that the point charge electron should not exist in the atom. The only stable structure of the two stationary opposite charges is that the electron forms a surface charge around the nucleus, as is shown below. The charge of the electron should remain the same, which is consistent with charge conservation. Based on the stability concerns of the two opposite charges in the atom, it is suggested that the electrons go through a phase transformation from point to surface charge and vice versa when captured by or freed from the nucleus. The point charge or free electrons, compare them to the captured or bonded electrons in the atom, behaves differently. These differences are listed here, and the different behavior of the free and the captured electrons further supports the proposed phase transformation of the electron, concluded from stability concerns. Further support of the phase transformation of the electron comes from the quantum mechanical description of the electrons. The normalized wave equation of the hydrogen atom is shown below, and this equation describes the three-dimensional vibration of a spherical shell. This description is fully consistent with the proposed surface charge electron shell model. The surface charge electron shell model offers physical explanation for the characteristics of the hydrogen atom. Like the constrained size of the shell explains the restriction on the wavelengths. It also explains the quantized nature of the momentum and the energy, the photon emission and absorption, the long-term stability of the atom, and gives the correct value for the ground state angular momentum. From this list, photon emission and absorption is explained a little bit more details below. On the left and right of the figure, shown a stationary vibration of the electron shell. During this stationary vibration, the vibration is completely symmetrical, which results in a complete destructive interference. So no emission occurs, neither of these cases. Emission occurs only when the vibration switches from one stationary state to the other stationary state. And during the transition period, the vibration becomes non-symmetrical, and this is the time when photon emission or absorption occurs. This is ICCF 25, so the question should be raised, what is the relevance of this model to lattice confinement fusion? And the relevance is that the surface charge electron shell can shield the repulsion of the protons, and by this shielding, the two nuclei can get close enough for fusion. As a conclusion, the major statements of this presentation are outlined. Electromagnetism is valid at atomic scale. The stability of the atom requires surface charge electron shell in the atom. The model, consistent with the quantum mechanical description of the atoms, explains the physics of the wave equation, offers physical explanation for photon absorption and emission and other atomic features, shields the repulsion of the protons if two atoms encounter, and explains how the two nuclei can get close enough for fusion. My message to the conference is that lattice confinement fusion is possible theoretically at low temperatures and pressures. The physical requirements for the fusion is discussed in my other poster. Please visit that one too. The title is Possible Physical Explanation for Lattice Confinement Fusion. Thank you for your attention.